Hello everyone. Today class number 16. Class number 16 for electrical machine 2. Class number 16 for electrical machine 2. Okay. So today I will start first some numericals. After that I will start the topic of the power basis theories. Okay, so write down first numerical. Today's numerical is regarding sleep. Numerical regarding sleep. Okay, so problem number 1. A sleep ring induction motor, right? A sleep ring induction motor runs at 290 rpm. Okay, sleeping induction runs at 290 rpm at full load condition. At full load condition. FL condition means full load condition. Okay, when connected to 50 hertz supply. When connected to 50 hertz supply, determine the number of poles and the sleep. Determine the number of poles and sleep. Okay, so actually you have to perform the sleep. Okay, ns equals to synchronous speed, we know, right? The formula equals to 120 fs by p in rpm. Okay, and it is in rpm, so you have to find the ns in rpm first. So ns equals to the sleep ring induction motor so given ns equals to 300 rpm. It is given to you, right? It is given. So 300 rpm is given to you, 120, and fs equals to supply frequency 50 hertz, and there are number of pole, unknown number of poles. So pole you have to find, right? So your answer will be 0 0 cancel out, 5 into 6, 6 into, that means how much? 20. So pole equals to 20. So 20 number of poles. So how much pole pair? So if suppose determine the number of pole pair. Number of pole pairs. Pole pair means P of P, that will be 10. That is pole pair equals to 10. Because every pair contains two poles, right? North pole and south pole. So, and determine the sleep. So sleep is equals to what? The formula of the sleep, ns minus nr with respect of ns, right? It is in pu, per unit. Okay, so your result will be ns equals to 300, nr equals to 290 by 300, 10 by 300, that is 1 by 3 pu. And if we find in percentage, then 1 by 3 into 100, just that will be 33.333 or 34%. Okay, so this is your sleep. Okay, so sleep. So first problem is very easy, and I am moving to the second problem now. Problem number 2. A 4-pole 3-phase induction motor operates from a supply whose frequency is 50 Hertz. Calculate Roman 1 speed at which the magnetic field of the stator is rotating. The speed at which magnetic field of stator is rotating. And second one, the speed of the rotor when the slip is speed of the rotor when the slip is 0.04 pu. Okay. And third one, the frequency of the rotor current when the slip is frequency of rotor current when the slip is 0.04 pu. That is for this case. And fourth case, the frequency of the rotor current, when the motor is standstill condition, when the motor is in standstill condition. Okay, so you have to perform these 4 questions. So let's find this NS. Always remember this type of question when it is being asked in your exam purpose, then always first try to find this NS. The formula equals to 120 Fs by P. So that means 120 into Fs is how much? 50 Hertz. And P equals to 4 pole, that will be 4. So your result will be 31500 RPM. Okay, 1500 RPM. So NS equals to 1500 RPM. So which is nothing but your first answer. See, the speed at which the magnetic field rotates, that is NS. Actually you are finding the NS. Okay, synchronous speed. The definition of synchronous speed is the speed at which the magnetic field rotates. Okay, so second one, speed of the rotor when the slip is 0.04. Now you have to find NR when S equals to 0.04. So from the definition of slip we can find S equals to NS minus NR by NS, right? So that means in PU it is given, so you can use this formula directly. So 0.04 equals to NS means 1500 minus NR you have to find, and NS equals to 1500. So multiplied over here, so it will be how much? 0.04 into 1500. If we multiply it, then it will be, okay, so no need to multiply. First you have to calculate it and directly you can find, right? So 1500 minus of this one equals to directly NR. So NR equals to 1500 taking as common 1 minus 0.04. So that means how much? It will be 1440 RPM. Okay, 1440 RPM. Okay, so NR equals to 1440 RPM. So second problem is completed. So now I will move into the third problem. So the formula, the speed of the rotor when the slip is, okay, this is completed. So actually you have to find this NR. Okay, now, and the third one, frequency of the rotor current. Frequency of the rotor current means what? So you have to find F dash. F dash equals to S into Fs. Always remember, or frequency of rotor current you can say Fr. Okay, Fr equals to S into Fs. Slip, what is the value of slip? That is 0.04. It is given, and Fs equals to 50. Just multiplied with 0.04 into 50. So that will be equals to how much? It will be equals to 4 by 100 into 50. So that means 2. That equals to 2 Hertz, right? F equals to F1 equals to 2 Hertz. And fourth one, that is the rotor current when the motor is standstill condition. That is F1 equals to again S into Fs. So rotor standstill condition means how much? What? Standstill condition means S equals to 1. There is all total slip is acting on this motor. So that means Fr equals to 1 into 50. That will be 50 Hertz. See, for standstill condition, whatever the frequency of the stator part, which will be exactly equal to the rotor part. Okay, for standstill condition, Ns equals to Nr. Sorry, standstill condition Nr equals to 0. That means S equals to 1. That means R equals to Fs, right? So this concept, from this concept you can say the 50 Hertz will be the rotor current frequency. Okay, so this is for all about your second problem. Okay, so let's go to the third one. Okay, so question number 3. A three-phase induction motor is wound for 4 poles and is supplied from 50 Hz system and is supplied from 50 Hz system. Okay, and supplied for 50 Hz system. Calculate Roman 1, the synchronous speed. Roman 2, the rotor speed when sleep is 4%. The rotor speed when the sleep is 4%. And third one, rotor frequency. Rotor frequency when motor runs at 600 rpm. So these 3 questions you have been asked. Okay, so let's do it. So synchronous frequency means nothing but ns. So ns equals to 120 fs by p, very much popular formula. Fs equals to 50 Hz and pole equals to 4 poles. So that will be equals to 1500 rpm, right? 1500 rpm. Their first answer will be coming. So second one, rotor speed when the sleep is 4%. So sleep equals to 4%. So it is given in percent. So that's why sleep S equals to ns minus nr by ns into 100. It is given, right? It is the formula for sleep. That will be 4. Ns means what? 1500, and nr should be calculated. The rotor speed should be calculated. That is nr should be calculated over here. So ns means 1500 into 100, right? So 0 0 cancel out. So 15 into 4, that will be 60, equals to 1500 minus nr. So nr equals to 1500 minus 60, that will be equals to 1440 rpm. Okay, so now third one is rotor frequency when the motor runs at 600 rpm. So here nr equals to 600 rpm is given, and you have to find AFR equals to question mark, right? So we know AFR equals to what? Sleep into Fs, right? So sleep equals to, you have to find when the motor runs at 600 rpm. So sleep will be different for here. So sleep equals to 1500 minus 600 by 1500, right? So this is, always remember, when you are finding the frequency, try to find the sleep at per unit system. Okay, so the sleep is at per unit. So no need to write, no need to multiply the 100 over here. Okay, so this is your sleep when the speed of the motor is 600 rpm, right? Ns minus nr by ns, that is 1500 minus 600 by 1500 into Fs equals to what? Fs equals to 50 Hz. So your answer will be 0 0 cancel out, 5, that will be 30. So 900 by 30, that will be equals to 30. So Fr equals to 30 Hz. Okay, so this is all about your third problem, which is very easy, and this type of question is frequently come in your exam purpose. Okay, within a minute you can do this type of numerical, within a minute. Very easy type question. This is. And now I am looking into problem number 4. So fourth problem, write a 12 pole 3-phase induction motor. 12 pole 3-phase induction motor driven at a speed of 500 rpm. At a speed of 500 rpm. Supplies power to an 8-pole 3-phase induction motor. Okay, so first one is not motor, it is a alternator, right? So this 12 pole 3-phase alternator driven at a speed of 500 rpm supplies power to an 8-pole 3-phase induction motor. That is a generator, 3-phase generator is supplying a 3-phase induction motor. Okay, so that means it is a generation, it is a supply system. The alternator is a supply system. So alternator is a supply system. Okay, so you have to find if the sleep of the motor at full load is 3%, if the sleep of the motor is 3% at full load, FL, that is full load, calculate the full load speed of the motor. Calculate the full load speed of the motor. Okay, so you have to find the full load speed of the motor. So here basically you have to first find the NS. So what is the NS? Everyone will do this mistake. This 12 pole is for alternator. Okay, so P equals to 8 pole over here. Okay, so AP equals to 8, Fs equals to 50 Hertz. That is Fs you have to first find due from this concept. Okay, so right, as the motor runs, as the alternator runs 500 rpm, runs at 500 rpm, therefore we can set NS for motor equals to 500 rpm. So therefore 500 equals to 120 Fs by 12. Let us find first Fs, frequency of the supply system. Fs is frequency of the supply system. 500 12 by 120. So 0 0 will be cancel out. 12 that will be 0 0 cancel out. 12 that will be cancel out by 1. So 50 Hertz, right? So 50 here you can say that the 50 Hertz supply is given to the motor. So now you can find NS equals to actual NS, that will be the for motor 120 Fs by P, which will be equals to 120 into 50 by 8, right? So which is that will be equals to how much? So from cancel out by 4, that will be 2, cancel out by 4, that will be 30, right? So it will be 15. So 750, right? So 750 rpm is your synchronous speed. So now calculate the full load speed when the sleep is 3%. So S equals to NS minus NR by NS, right? So sleep equals to 3%. So multiplied by 100 because it is given in percentage. So 3 equals to NS means 750 minus NR by 750 into 100. Okay. So just calculate it. 0 0 will be cancelled out. 50 into 3 or first cancel out by 5. That will be 15, that will be 2, 45. So 45 equals to 1500 minus 2 NR, right? So 2 NR equals to 1455. So NR equals to 1455 by 2. So it will be around your 727.5 rpm. Okay, 727.5 rpm. Okay, so this type of question is very easy, and this type of question is basically being asked depending on the sleep concept. Okay, so today's class up to this much. Waiting for next day. Next day I will start the different relations of power of the 3-phase induction motor. Okay, so today's class up to this much. Thank you.